So this will be the second lecture for the circle part, and today we will start from the tangents, and then we will go to the insight of normal, common tangents, polar of a circle, length of the transverse common, and other type of common tangents are also there, right? So let's start. Tangents. So suppose a circle is there, suppose a line lies here, and let us consider the radius of the circle is r, and the distance of the center from the line is suppose d. So if d less than r, if the distance d is less than r, then we will say that that line is secant, right? Secant. That means that line is here, right? If d equals to r, then the line is tangent, and if d greater than r, then this line is lying just outside the circle. And if d is 0, then this is just a diameter, you can say the line is the diameter, right? So let's start with the equation of tangents. Equation of tangents, right? So equation of in equation of tangents, as you have done in straight line, there are three different types of form is there: slope intercept form, slope form, point form, like that. In the same here also you will get the same like that. Here the first one is point form. If the equation of the circle is x square plus y square equals to r square, that is passing through the radius, then its equation of the tangents at x1 y1 is xx1 plus yy1 equals to r square, right? This is the point form. In case of slope form, let's go to the new page, otherwise it is quite big and I need to derive this one. So the another form is slope form. So in slope form, if the circle has a tangent y equal to mx plus c, and the equation of the circle is x square plus y square equal to r square, and let us consider the equation is y equals to mx plus c, then put the value of y in equation of the circle, then you will get x square plus mx plus c whole square equals to r square. If we calculate, you will get like this. This is quadratic in x. The equation is quadratic in x. So x square 1 plus m square plus 2mcx plus c square minus r square equals to 0. We know that the circle and the tangent that intersects at a single point, if it intersects at a single point, then this quadratic equation must have two roots that are same roots. For same roots, what we know, discriminant value is equals to 0, that is b square minus 4ac is equals to 0. If we calculate, we will get like this, minus 4 c square minus r square 1 plus m square equals to 0. And if I further do the calculation, we will find that it is coming c square equals to r square into 1 plus m square. This is the equation condition. Then c is equals to r root 1 plus m square plus minus. So this c should be replaced with this term. Then what it will come? Y equals to mx plus minus r root over 1 plus m square. This is also called equation of tangent in slope form, right? And suppose the equation is y equals to mx plus c, and the equation that corresponds to point form is x1 plus y1 equals to r square. Then what we should do? We should take like this, and x1 plus y1 minus r square equals to 0. If we want to get the value of the point of contact, then we are going to just divide the coefficient. Ratio of coefficient must be equal. That is, just see here, the ratio of coefficient is 1 by y1 sorry wait a bit. Just a minute. So it will be the ratio of the coefficient should be equal. That is, ratio of y here is 1 by y1, ratio of x is minus m by x1, and the ratio of that this part is, let us say, minus c over minus r square. Then what will be the point of contact? You are getting y1 is r square over c, x1 is minus mr square over c. These are the point of contact. That is mr square over c, r square over c, point of contact. Don't compare only the coefficient, that is x equals to minus m. Always do the ratio, right? The ratio is equal. Okay, so let's go to the new slide. If the circle is given in, let us say, in this manner, the equation of circle is given in this manner. C equals to 0, then at point x1 y1 the equation of tangent will be xx1 plus yy1 plus, instead of 2x, it will be g into x plus x1 plus fy plus y1 plus c equals to 0. That is, x square is getting converted to xx1, y square is getting converted to yy1, 2x is getting converted to x plus x1, and 2y is getting converted to y plus y1. So this is the equation of tangent, right? Equation of tangent. If you need to write in parametric form, we know that in parametric form, if it passes through origin circle, then its x is equals to r cos theta and y is equals to r sin theta. Then it's let us consider the circle passes through origin is this. Then what will be x into x1? x1 means r cos theta plus y into y1 means r sin theta equals to r square. Then in parametric form you will get like this, equation of tangent in parametric form. In parametric form, in most of the problems, I am assuring you, you should use the slope form. This form has many more application. Almost 80% of the problems will be done using this slope form. So now I am going to have some idea about the length of the tangent. So length of the tangent, so length of the from the length of the you know that suppose a point that lies externally is x1 y1, and suppose BP is a tangent, then what will be its length? To get, suppose this is the center O, then we know that BP and OB always perpendicular. The tangent line and the line that joins from the center to the point of tangent that lies on a circle is always 90 degree. That means OBP is a right angle triangle. We can use Pythagoras theorem here. So if I use Pythagoras theorem, then OP square equals to, suppose, OB square plus PB square. Suppose this one is 0 0. Suppose considering the center is lying on the center of the circle is lying on the origin. Okay, then OP square is OB square plus PB square. Pythagoras theorem. What is OB? OB is radius, and what is PB? PB is the just PV square. We can't get the value of PV. We need to have the value of P. What is OP? OP is x1 square plus y1 square that we get from the distance formula. Then PV square is x1 square plus y1 square minus r square. That is PV, that is length of the tangent, is x1 square plus y1 square minus r square. Writing the let us consider the equation of circle is this one, equals to r square. If that is x y square minus r square equals to 0 equal to S circle, let us consider this S. If x is changing to x1, then we are denoting this S to S1. Then what we can write, this is root S1. That means this is the length of the tangent. Clear? Now what is power of a point? Power of a point means that when a secant and a tangent meet at a point. Suppose I am writing power of a point means that suppose a circle is there, suppose a tangent and a secant. Suppose this is a secant, this is the tangent, and that meet at a point. Suppose this is x1 y1. Suppose this is PA, suppose this is B, this is M. Then what is the power of a tangent? Power of a tangent is PA dot PB equals to AM square. This is power of a tangent. That is AM square means the distance, that is the tangent length. And what will be the tangent length? We know that x1 square plus y1 square minus r square. That is, you can also say s1 square, or we can also say, suppose I'm going to write it as t square. Suppose the tangent length. Then if PA and PB is written like this, then we can write S1 equals to t square. Clear? This is the power of a point. And if we consider the pair of tangents, the same equation will be followed. If we consider pair of tangents, suppose like this, then also we are going to follow the same form, S1 equals to t square, that is x square plus y square minus r square into its corresponding x1 square plus y square y1 square minus r square equals to x1 minus plus y1 minus r square whole square. This is the condition of the pair of tangents, and there will be three cases. Power of a point outside the circle is always positive. Power of a point inside the circle is negative, and the power of a point on the circle, suppose this A is lying on the circle, then it will be 0. Then if it is lying on the circle, then PA equals to 0, because P and A are coinciding each other, they are the same point, so we say that power of a point lying on the circle is 0, right? Now let's go to the normal. So suppose whenever we are doing normal, let us draw like this. Suppose center is 0 0 origin, and suppose the point is x1 y1, whatever we have taken in tangent. Whenever we are writing the equation of normal, we should consider the slope first, slope of the tangent first. If the slope of the tangent, let us consider, is m, then slope of the normal will be minus 1 by m. Then slope of the normal is minus 1 by m equals to y1 over x1. This is the normal. Then what will be the equation of the normal? Y minus y1 over x1, x minus x1, x minus x1. From here you can say that y1 over y, x1 over x. This is the equation of the normal. Okay, so if we consider the second degree equation, suppose second degree equation, I have told number of times 2gx plus 2fy plus c equals to, this is the second degree equation. Normal to this second degree equation is what? We often write in this manner: ABC for memorization, HGF for memorization. It will clear you. First write the diagonal ABC and then write the upper triangle HGF, lower triangle HGF. Clear? So normal, the equation of normal to this second degree equation will be x minus x1 over x1 plus b hy1 plus g equals to y over y1 by hx1 plus by1 plus f. This is the equation. If the circle, if any normal, I am considering the second degree equation. See, this is not a circle equation. If I consider the special case circle, then you will see that h is 0, then it will convert into x1, suppose and a equals to b equals to 1, a remove that, x1 over z, y minus y1, h is 0, b is 1, y1 plus f for circle, right? I think it is clear about this part. Is there for normal, nothing more than that. And the next part is the chord of contact. It is very easy. What is the chord of contact? Suppose if we draw a pair of tangent, and suppose this is the pair of tangent, and from the point that tangents that is passing from the point that lies on a circle, if we draw the line, then this is known as a chord, or this is known as chord of contact. Clear? Suppose I am writing the coordinates. Suppose this is x1 y1 x2 y2 x3 y3. Equation of the chord of contact is same as that of tangent, right? If we write AB is the chord of contact. Equation of chord of contact is same that of tangent, but the point lies outside the circle, while in case of tangent what we have done, it lies on the circle, right? So if the circle equation is this, then its corresponding chord of contact equation will be same that of tangent, but the point lies outside, x1 y1 lies outside. Clear? Now the next topic is chord passing. So suppose this is a circle, and suppose this is a chord AB, and this is a center. I am drawing a perpendicular to the chord, so that this length, if it is perpendicular, this length and this length must be equal. If the slope of suppose this is m, slope of CM is suppose this point is x1 y1 and this is 0 0, equation of circle is same. So what will be the slope of CM? It will be y1 by x1. Then what will be the slope of AB? As CM perpendicular to AB, the slope of AB will be minus x1 over y1. Then if I write the equation, then I will write y minus y1, m of AB, that is this. From here you will get x1 plus y1 equals to x1 square plus y1 square. Clear? See, y1 minus y1 square minus x1 minus x1 square. If we take the positive part along each side, one side, then you will get this type of equation. If we just write r square, suppose x1 plus y1 minus r square, x1 square plus y1 square minus r square, then I can say this is the tangent and this is s1. So equation of chord of contact is this, right? And equation of chord of contact, and this is equation of chord passing, right? And the equation of chord of contact is this. They are different. You must remember this one, don't be confused. Now let us come to the part directed circle, intersection of two circles, length of common tangents is also there, angle of intersection, many more parts are there, but still if we discuss in brief manner, then it will be much more easier. Alright, so let us start in a new topic, directed circle. So directed circle, what is a directed circle? Suppose this is a circle and suppose we are drawing a pair of tangents like this, and this is the center like this, and suppose we are naming TAB, and this is the center C, that is 0 0. If that angle, this angle is 90 degree, that means APBO is a square, then the locus of P is also called directed circle, because we will be getting an equation of circle, that's why the name is given director circle. So if I join from P to B, you will get this one as 45 degree, and PAO, this is a right angle triangle. From here we can say sine 45 degree equals to, this is radius, suppose R over CP, this one is C. Clear? Then what is CP? What is CP? You can if this one is suppose HK, then CP distance we can say h square plus k square, it's root over, then R is root h square plus k square, sine 45 is 1 by root 2. If we square both sides, we will get like this. To get the locus of P, what we normally do, we change h to x and k to y. So the locus of P is x square plus y square equals to 2r square, right? So this equation, or this is known as director circle, right? This is known as director circle, and the radius of director circle is root 2r, right? Don't write 2r. So this much you will have in director circle. Now let's come to the part intersection of two circles. If you understand the concept, then it is very easy. The chapter is bigger, but it is easy. Suppose the two circle, if the tangent that is drawn from the circle C, suppose S1, that intersects S2 along same direction, like then this is known as direct common tangent. Direct common tangent intersection. If the tangent from a circle S1 that intersect S2 at the opposite end, suppose this, like this, then this is called transverse common tangent. So let us write, suppose this is center is, suppose this center is C1, this center is C2. Suppose this is point, let us consider it as suppose J, and let us consider this one as suppose E, right? So we will be having some conditions. If that C1 C2 means this distance, right? This distance, if that C1 C2, this point will be same, right? This point will be same. If this mod value of that distance between the two centers is greater than R1 plus R2, sum of the two radii, that means they are far apart, then we will be having four common tangents, right? Two transverse and two direct. One thing you must know, if I write C1E over C2E, this is the ratio of the distance is same as r1 plus r2, but this is externally for internal point j. This is internally, right? Suppose mod c1 c2, the distance between the center of circle s1 and s2 is greater than the sum of the radii, then we will be having 4 tangents, 2 direct common tangent and 2 transverse common tangent. 4 tangents, 2 direct, 2 transverse. If the value, suppose c1 c2 is equals to r1 plus r2, that means the two circle are just touching each other like this, then we will get just one transverse common tangent. 3 tangent possible, 2 direct, and wait a bit please. So 2 direct and 1 and 1 transverse, right? If mod c1 c2, that is the distance between the two centers, is less than the sum of radii, then we are going to get a chord. The transverse common tangent is just a chord. We are not going to get a transverse common tangent. Instead of that, we are going to get a chord, but still we will get 2 direct common tangent. It will look like this, right? And this is the direct common tangent, but instead of transverse common tangent, we are going to get a chord, right? So, and the last condition will be if c1 c2 less than the difference of the radius, then suppose it will look like this. Suppose the bigger circle is this and the smaller circle is this, right? The bigger circle is radius of r1 and the smaller circle has a radius of r2. Suppose it is like this. Wait a bit, I'm drawing. This is r1 r2. Then what I will say, there will be no direct common tangent because circles s2 is lying inside the circle s1, but one transverse common tangent is there, just like this. It will be like this. Okay, circle will be like this and this circle will be like this, right? This is the one transverse common tangent, one, that is the transverse common tangent, and all other tangents are imaginary, right? Sorry, I have told something wrong. Sorry, this will be equals to, sorry, this will be equals to, otherwise it will not lie. It will the small circle will not touch the bigger circle, and if it is less than r1 minus r2, then there will be no such common tangents possible, right? Now let us go to the part length of that common tangent. we will always calculate for the direct common tangent, because for the direct common tangent the calculation is possible, right? Just wait. Now calculating the length of the direct common tangent. So length of common tangent, right? So let us give an idea. Suppose I am drawing a direct common tangent like this. Radius of this is r2, smaller circle radius is r2, and the bigger circle radius is r1. And suppose we are joining the centers of the two circle C1 and C2. So let us consider the distance between C1 and C2 is d, suppose, right? So let us consider this is d. If I draw a parallel line from this C2, suppose this parallel line, then this part will be the rectangular part, A, C2, B and D. This is the rectangle, we can say. Then this distance is also R2, right? And dB distance is also same as this distance, C1, suppose this is A, C2A equals to BD distance, that is the length of direct common tangent. We are considering the case of this, right? If I consider this, then suppose considering this, we are going to get C1 C2A is a right angle triangle, right angled at A, as I have considered this one is a rectangle. If I do Pythagoras theorem of C1 C2 A triangle, this suppose it is like this, right? It is not like this, it's like this. This is the rectangular part and this is the triangular part, right angle triangular part. So if I consider the right angle triangle C1, this it is C2 and this is A and this is B, this is D. For this right angle triangle, we know that C1 C2 square equals to AC1 square plus AC2 square. What is C1 C2 square? I have told that this one is D square. What is AC1 square? AC1, see, this part is R2 and this overall part is R1. Then AC1 is R1 minus R2. This part will be R1 minus R2, that is R1 minus R2 whole square, plus AC2 square is equal to BD square, as it is a rectangle. Then BD square equals to D square minus R1 minus R2 whole square. this is I am doing the calculation of direct common tangent. Okay, so BD, the distance, will be root over of that. So suppose BD, then BD equals to root over of this. This is the length of direct common tangent. So if you want to do for the transverse common tangent, you will see that quite similar, but it will be just added, the radius is added. This is for transverse common tangent, right? I have done the derivation part for direct common tangent. Now let's go to the part common chord. Okay, what is a common chord of a two circle? When a circle, I have told that C1 C2 less than R1 plus R2, then we are, instead of transverse common tangent, we are getting a chord, that is common chord. Suppose the equation of two circles, suppose this one is S equals to 0. S means x square plus y square plus 2g1x plus 2f1y plus c1 equals to 0. And suppose this one is s1 equals to 0, s2 equals to 0, and that is x1's wait a bit, s1 you don't need to write. Suppose s dash, s and s dash, that is s is defined as x square plus y square plus 2gx plus 2fy plus c equals to 0, and s dash is referred by x square plus, suppose write g1 f1, because you are going to define it for s2 also. So it will be d2x plus 2f2y plus, suppose this one is c2 equals to 0, let us write c1, it will look good then. So for the equation of common chord, equation of common chord, what we are going to write, s minus s dash equals to 0. This is the equation of common chord, right? And if the length of the common chord is 0, then we will say that it is a tangent, right? If the length of the common chord is 0, then it is a tangent. What is the length of that common chord? The length of the common chord, if you need to measure, then just a minute. Suppose this is the chord, right? And like this is 90 degree, this is the center C1, this is C2, and suppose this point is A, let us consider, right? So what will be the length of the chord? Suppose the point, this point is M, length of the chord will be 2m, because these two lengths are equal. Length will be 2am. What is am? From Pythagoras theorem we can write root over of a c1 square, which is the hypotenuse, and c1 m square. In this way we find the length of common chord. So, and another part, which is pole and a polar of a circle. What we normally do for pole and a polar, suppose a secant and a tangent we have drawn. A secant is externally extrapolated, so that it intersects the tangent at an external point to the circle. If we draw some pair of tangents, just a minute, I have discussed one wrong part. Drawing 2 seconds. Somehow I have told about the previous part, right? So don't be confused with that. I have told about the power of a point, so don't be confused. Even I have got confused at this moment. So this part you need to focus more, because it's a conceptual part, right? So when 2 seconds are intersected externally, we will see that each second has to pass through the 2 points of the circle. So if we draw a pair of tangents from the 2 seconds, suppose drawing a pair of tangents, right, from the 2 seconds, suppose it intersects at P and P dash, then what I will say, this line joining P and P dash is the polar line, right? Line joining P and P dash is a polar line. Is the concept is clear? Let us consider the point of P dash is HK and the external point is suppose x1 y1. Then what will be the locus of point? Suppose this is M. Locus of point M will be x1 plus y1 equals to r square. The equation of circle is x square plus y square equals to r square. It is same as that of chord of contact. You can say this, suppose this is AB, this is the chord of contact. Okay, so locus of M will be quite similar to the chord of contact. You can say exactly same, because if we extrapolate the chord, then we will get the point M that lies on the external extrapolated part of AB, right? So this is the concept that you are going to find in polar. So let us consider you need to find the pole, coordinate of the pole. Then how to find? Suppose the equation of the polar line is given. Suppose equation of the polar line is x plus by plus c equals to 0, and the equation that we made, that is x1 plus y1 equals to r square. So if we compare the two equation, you are going to get the coordinate, right, point of contact. The same way I have told, just go for the ratio. You will get point of contact, that is coming a minus a r square over c minus b r square over c. Clear? Now let us complete the few part. I guess it will take 20 minutes, not more than that. I will try to try to make the video not very big, because it would make you bored. Okay, so now the next part is angle of intersection of two circle. Derivation part is not required. Okay, I am not going to do the derivation part. It will be completely a wastage of time, right? Suppose this is the two circle. and the tangents are like this. Sorry, suppose we are drawing a tangent like this. The angle between the two tangents is theta, and suppose this is center C1, this is center C2. Then theta is the angle of intersection of two circles. How to calculate theta? Suppose the first circle has radius r1, second circle has radius r2, and the distance between their two center is d. I am saying again, the first circle radius is r1, second circle radius is r2, and the distance between their two centers is d. Then cos theta is r1 square plus r2 square minus d square over 2r1 r2. In this way we can get the value of theta by making cos inverse of this part, right? If theta is 90 degree, then we will say that the two circles are called as orthogonal circle, right? If the two circle is orthogonal circle, then as equation which one is getting which will be satisfied, that is, if the two equations are x square plus y square plus 2gx plus 2fy, suppose g1x f1y plus c1 equals to 0, and x square plus y square plus 2g2x plus 2f2y plus c2 equals to 0, then what you are going to get for the orthogonality condition? You are going to get c1 plus c2 equals to 2g1 g2 plus 2f1 f2. This condition is used in many problems. Try to remember this condition, orthogonality condition, when the angle between the two tangents is 90 degree, that is the intersection of two circle, theta is 90 degree, that is their perpendicular, right? Now let us come to the part radical axis, and there are many more new keynotes, right? Many more new terms are there in circle. What is radical axis? Actually, when the tangents from a point which were equal in length, which are drawn in two circles, the locus of that point is the radical axis, locus of that moving point. Suppose I have told the tangent drawn to the two circles, suppose this circle and suppose this circle, which are equal in length, then the locus of that moving point is the radical axis. Clear? Right? Suppose I am writing this is P, this is suppose M, this is N. If PM equals to Pn, then we say the locus of point P is a radical axis. So if we suppose this one is minus g minus f minus g1 minus f1, these two are the center coordinates, and P, suppose this is, let us consider this is HK. Wait a bit, I need to rub it. So this is HK. So if we let's try to recall the distance of the tangent what we have done, it will be, as far as I can remember, it will be like this. Suppose if uh, h square plus k square plus 2gh plus 2fk plus c equals to root over h square plus k square plus 2g1h plus 2f1k plus c1, right? So if we square both sides, h k will get cancelled and we will get like this, 2h g minus g1 plus 2k f minus f1 equals to plus c minus c1 equals to 0. So if we write the locus of p, that is equation of radical axis, locus of p will be, change hk to xy, you will get 2x g minus g1 plus 2k f 2y f minus f1 plus c minus c1 equals to 0. That is, you can say, if this is s, this is s dash, then s minus s dash equal to 0. Ultimately you are getting. So the last topic is radical center and coaxial system of circle. What is the radical center? If we draw with respect to three circles, suppose these are the three circles, and the radical axis with respect to these two circles is this, with respect to these two circle is this, and with respect to these two circle is this. The point of intersection of three axes, that point is known as the radical center, and from that center the tangent length to each of the circle is known as radical radius, right? So now let's go to the part coaxial system of circle. What is coaxial system of circle? Suppose this is a circle and this is the, suppose this is another circle which has a common line. Suppose this is another circle, bigger circle, that is family of circle that is having a common chord, this line L equals to 0. Then what will be the equation of that family of circle passing through that suppose AB? You will write S plus lambda L equals to 0, right? If the equation of that circle is S equals to 0, S means x square plus y square plus 2gx plus 2fy plus c equals to 0, right? And how to find the length? Length, this is not the length, this is the equation of that common chord, S plus lambda S minus S dash equals to 0. Clear? You will be having this part in the coaxial system of circle, and the last part is limiting point. It is those circles whose radius is 0, that is coaxial point circles. Family of coaxial point circle are called limiting points, right? Suppose if we consider the circle that lies on x-axis, center that lies on x-axis, then the equation will be like this, 2gx plus y square plus c equals to 0. Then center from here we can say minus z0, For limiting point, we say radius is 0, that is e square minus c is equal to 0, that is z equal to plus minus root c. So center will be root c 0 and minus root c 0. If we form a circle using this as a center, then we are going to get coaxial system of point circles. Now if c, the value c is greater than 0, then it will we will say distinct center. Greater than 0, then we are going to get distinct center. If, because here positive, here negative, if c equals to 0, same center. If c less than 0, then imaginary center, right? So this part, this is the overall overview I have told about the circle. I guess you need to go through the any book for more clarification. You may get some other formulas, but try to avoid that, because it may make you clumsy. So thank you. So I'm ending my lecture today. We will be having exercise session in the next lecture, and I will conclude the circle in the next lecture. Thank you.